Hello again, Register audience. Welcome back. We are live again today. If you're joining us from the Register front page, hello, welcome. You are very welcome. We are going to be talking about the bridge to application modernization today. We're going to be building the bridge and helping you to get across it. Well, as always, I say we are. I'm not going to be doing much of the work. Today we have, I don't know whether this is easier to remember or makes it harder to run, but we have two Johns. So welcome. John Prot, welcome back. Actually, you've been on our Regcast before.
Yes, thank you for having me.
Now, remind me, John, what does Stromasys do?
So Stromasys publishes a software which emulates legacy hardware. Basically, we sell software, but in fact, we sell panic control, or we sell risk mitigation. Depends how you want to put it.
Yeah, we're going to get into a lot of the details about exactly how you do that and how it works, because it is a little bit like, can it really work? And well, we found out last time, yes, it does. And we're going to find out, particularly in this circumstance today, in this context, exactly how well it works. And helping us with that is Jonathon. Hello, Jonathon.
Hello.
Now, Jonathon, which bit of Microsoft are you in?
Yes, great question. Thanks for asking. So I am with our Azure Global Engineering Group. So it is a group within the engineering department at Microsoft who's focused on making Azure the best place for all workloads, which includes an area that I focus on in my group, which is what we call legacy. And that includes artifacts that are mid-range. So a lot of the portfolio that Stromasys works on and their emulator works on is overlaps with what we are looking to build a bridge and a pathway into Azure for. Also, we do mainframes and other variants in that space. But essentially, our group is focused on the engineering side, reference architectures, working with customers, working with partners to help them with that pathway, give them the right technical guidance, and then concurrently making Azure the best place possible. Because we are part of the engineering group, we do engineering feedback, and we try to figure out where those boundaries are, where we can improve things, smooth pathways in order to have these complex and quasi-complex systems and get an easy pathway into Azure for them.
Is this a growing part of the business, Jonathon?
It is. Yeah, we've seen a lot of growth in this area across international, U.S. federal, international government. As John mentioned, risk mitigation is a key piece here. And as these systems are aging, and as folks are starting to retire that have these skill sets, wanting to put them into a modern framework, modern cloud is a real growth area. And then what we'll get into in the presentation is talking about how there's various ways of doing that also have lower risk options, which is what Stromasys can provide in that space. But indeed, it is a growing area. We're seeing a lot of interest, and a lot of great new things are coming out in terms of how we can create modern reference architectures to combine and to make things the best possible with the legacy plus the modern things that Azure provides.
And for any of you who are watching today, if you're in charge of a legacy application and you're sitting there worried every day in case black smoke starts coming out of it, and you're thinking, what do I do about this? Well, we're going to be helping. There's plenty of practical information about this, not just about how you plan what you do and how you scope out what you do, but actually what it means, what's actually going to happen if you want to move these apps to the cloud. Now, now don't forget as well that because we are live, you can ask questions, you can tell us what your opinion is, you can share your experience if you like. And so between the two Johns, they can answer any question that you've got. I can totally 100% guarantee that. So ask away if you want, and I'll put the question to them. So first of all, we're going to be looking at how those legacy workloads, what a drag they are on your business, something you're going to probably be aware of, but we'll just look at your options. And then we'll be looking at how we bridge to the cloud and what that means. And then how that means that, that's not just a one-off thing. That is that's a gateway to being able to then modernize from there. And so it's an interesting story. And so first of all, John, start us off on this, though. The legacy workloads, I said they're a drag on the business. That's true, isn't it?
Absolutely, and anything old, really. I mean, there is this saying that software with time gets better, hardware with time gets worse. Unfortunately, like our bodies, at least for most of us. And well, when we look at legacy, we need to separate between hardware and software. And that little chart you have there at the bottom, the green ones are the applications. That's your stack, and then on that stack, the applications are sitting on your operating system, and then it's sitting on hardware. And as time moves on, hardware needs to be refreshed maybe every 5 years, and the OS needs to be refreshed, I don't know, every 10 years or 7 years. But the application needs to live on many occasions, and the reason for that is that an application encompasses the company's wisdom. Why a company exists is really enshrined inside this application. It's all the processes of the companies, of how you mix chemicals maybe, or all your IP, if you're a semiconductor company, all your designs, all of that, the years and years that took you as a company to evolve is inside your application. And when the hardware goes out of, not fashion, but out of existence, really, because it's old, then you got a problem. And I invite you to notice the gaps between each green bar or between each blue or orange bar, because that's when the problem is there. You have, sometimes when you jump from one bar to the next, there is no backwards compatibility. So you got an application running which was fine on the previous hardware, and they have this shiny new wonderful hardware, because of course the hardware manufacturers do need to evolve their technology, but at some point they need to break, and they say, sorry, it's not going to work anymore, and then you got a problem.
Yes.
So
and you have set out a couple of statistics for how big this problem is now.
So yeah, I mean, there's been many studies here, and there's a study by Forrester that hardware failure accounts for about 1/3 of any unplanned downtime, or that almost 2/3 of Fortune 500 companies have experienced at a minimum of 1.5 hours per week. That's average. I think these numbers are terrible. They don't look that terrible maybe on paper, but they should be zero. You should be planning for 0 downtime, and then you'll get some. If you're planning for 1/3 downtime or for an hour average, then you're going to face a lot more of that. And also, you know what? A downtime of 1 hour, how do you restart? I've seen old VAXs that took 8 hours to restart in a mission critical defense environment. So yeah, okay, it's down. Everybody focuses, oh, how long were you down? But how do you restart? And also, what does it mean for you? Well, what does it mean if you're a chemical company and you've got some assets lurking around while your IT is down, or you're a nuclear power plant, or you have a defense operation? You're going to shut down your airspace control for an hour? Or what if your HR records are there and you're about to go to payroll and maybe in a few hours and it's done? What does that mean for you? What if it's your ERP, your customers? Can they disappear? Is that okay? So yeah, we should not be planning on downtime ever. We should be doing everything we can to eliminate it.
I mean, I was joking at the beginning, but it is a very serious matter, isn't it? If you have aging infrastructure there, because there's not a great deal that you can do about that when that stuff isn't being made anymore.
Well, now you can, because you got me and Jonathon. But but really, yes, that is the core of the problem. That unfortunately, technology moves on, and everybody loves to talk about the new technology and AI and all these wonderful things coming on board. What they don't realize many times is that for the real world, the real industry, to follow and put their arms around that new architecture and that wonderful new technology, it's not that simple, because lives depend on it, processes depend on it. In fact, the airplanes you fly, probably the clothes we're all wearing today, the technology that we're communicating on, all of this is relying on legacy hardware and in general legacy IT, which is getting worse and worse.
Mm-hmm. And so our goal today is to get rid of the legacy hardware whilst retaining and improving, hopefully, the functionality of the application that's been running on it for however many, for years, maybe even decades.
Yeah, I would put two goals. One is to talk about what can you do, what are your options as a user, as an end user. The other one is to think about how can I plan this transition so that I do it on my terms, so that I'm not faced with a sudden elimination of a technology which is no longer there, and now I got to take a very expensive forced decision, basically. So we are all about helping, and we're very excited about what we do at Stromasys, because we enable customers to take decisions on their own terms. So the options here in this chart you have on the screen, the bottom left is do nothing. Mm-hmm. That seems the cheapest and the safest, right? Well, in fact, it's the most expensive and it is the riskiest, because as it gets older, there is a risk there which you don't see. But come on, we all know that it's there. Spare parts are disappearing. The humans that are maintaining it are disappearing, retiring, and you're stuck with some machines. I've seen machines being moved from data center to data center without being turned off. And I asked them, why are you not turning it off? Because we don't know how to put it back on. We don't know if it's gonna come back on. So it was a big spark, and in Europe, in a pretty mission critical business. So yeah, that's a problem. Wow. So yeah, the bottom left is do nothing, and Jonathon has a slide after that. Another one is to rely on spare parts and try to modernize your hardware by buying spare parts. That is a little cheaper, but it's still very, very risky, because spare parts have a shelf life. And spare parts on a 20-year-old machine, they weren't made yesterday. No. They were made maybe 10, 15 years ago. And therefore, they're old as well.
Yeah.
So, and plus, you don't know who used them before, if you're buying them from eBay, and you don't know what their real remaining life is. And then, of course, you have the long-term solution, which everybody thinks is the ideal, which is migration. It's more secure. It's more, it's the least expensive. No, sorry, it is the most expensive, but it is the most secure. The trick here is, again, the hidden surprises, because it always takes longer and it always costs more. If you start touching source code and you want to recompile, it will always be years. I'm not talking about a few months longer, but it takes years and it takes millions of dollars over budget.
So, and of course, if you are mission critical as well, then you have to go through a whole process of making sure that it's certified for whatever it's.
Yeah, that's a very good point, actually, because to reach, say you're controlling airspace, that means that your system is talking to all sorts of other systems that are controlling airspace. You got to make sure that they talk to each other. And to arrive at that securely, safely, you got to be certified. Sometimes the certification costs hundreds of millions of dollars. Whereas an emulator can cost, a small fraction of that, a tenth of that.
And that's where we are with the green square here. Lift and shift has a bit of a negative connotation, doesn't it? It's kind of like, it's got this idea that it's what people do when they run out of ideas. I imagine you get that a little bit, John.
We get that a little bit. Well, the first question that people have is, does it work? Does it happen? They don't believe that it can happen. For example, that, emulation, that tends to have sometimes a negative connotation. There's too much performance overhead. It's too slow. It's just not going to work. And 99% of our customers, once they see that it works, they actually do it. It's normal to not believe that it can be done, but we've been around for 22 years. We've done it in more than 70 countries and thousands of customers. So it's not always possible. We're not promising that, this is the holy grail. You just press a button and it's done. No, it's not for everybody. It's not for everything, but it's time to have this conversation of what is the right thing to do and what is the right way to do it and what's this right sequence to do things.
Jonathon, I'm going to bring you in here on this one now, because you have this slide with the sort of the potential migration paths that there are. Can you explain a little bit about what the difference is between them and who these apply to?
Yeah, excellent point to transition there. And just to pick up on John's point there, and that great 4-block diagram with the top right green block with the lift and shift. That's one term. Another term that we also like to use is rehost for that pattern. And what's interesting is that when it comes to lift and shift and emulation, you're not just locked into one pattern. Rather, we're finding that as we're going through and doing these patterns and we're doing these engagements in architectures, that we can do a hybrid where we can do a rehost or a refactor, where a component of that can be the lift and shift of the emulation technology, but we can concurrently take advantage of some of the new cloud technologies and create those and append those to the architecture. So you're starting to have that bridge to modernization where, yes, your core high-risk valuable infrastructure that you're now moving into the cloud, moving into Azure, you can bring that over, but then you can do small other changes to take advantage of, for example, virtual disk and virtual tape, which we'll get into with a later architecture diagram, is that you can leverage, for example, Azure Blob Storage, which is a serverless petabyte scale native cloud storage technology, low cost, that you can actually have your, for example, SPARC Solaris environment reading and writing to what it thinks is virtual, to physical tape, but under the covers is a virtual tape emulator that then is talking to and using Azure Blob Storage. So you're already just right there moving into this modern environment just by virtue of having that change and getting the best of both worlds. From there, you can also do other interesting things where you can do partial re-architecture aspects where, for example, you may, if you're running an Oracle database, that could be rehosted in the target environment and running on the Azure VM, which then runs the Stromasys technology that does the emulation, and that can work for some Oracle databases. However, if you want to break that out, you could have an Azure VM running the Oracle database, and then you're able to decompose your architecture a little bit and have some advantages of having the database running directly on the VM. That's one pattern. And then there's one more pattern as well, which we'll get into, which we can talk about API management, management gateway, and how you can actually create endpoints that abstract this legacy hardware, legacy artifacts, and that way you can have modern apps and modern technologies using it that aren't even aware it's legacy, and that can buy you time to figure out what you want to do in the future, that you can keep everything running as is, but eventually if you do want to do that rewrite, you possibly could, but as John said so well, it's expensive, it's complicated. Recompiling is hard alone, but then actually rewriting the code, where's the functional specs, where's the original architects of the code, all that has to come into consideration. If you don't have those things, then it's possible, but it's a very long road and can be very expensive. So this pattern and these patterns buy you time, give you options, and you can kind of find the right recipe that's the best of both worlds for what you're trying to achieve by doing that, using Stromasys emulation plus Azure to do that in the cloud.
I see. So while we often think about lift and shift as sort of like the final step in something, your vision is that it's the first step in something. You could actually do that, and then you could work out, okay, what do I do next? You can pick off what's best for modernization.
Precisely.
Or you can, for example, you can decide to move your application, as Jonathon said, to a native environment and keep your database to a native environment and keep the application running on emulation, which you don't want to touch, you don't want to recompile, you don't want to, and that can be a very long-term solution. I mean, we have customers running it for 10, 15 years.
Mm-hmm. Well, I guess there comes to a point where there are always plenty of things to do. So you might never actually get to the point where you do a whole rebuild project on that sort of, on that, because you've got many other things you want to do or in other parts of the business as well, but you can still modernize. Yeah. Okay, cool. Okay. Now, Jonathon, we are talking about the Azure infrastructure for this one, focusing on that. So the question is, of course, why you think it's appropriate for these kind of applications.
Yeah, right on there, Tim. So basically, when you're thinking about Azure, thinking about the cloud, and in this diagram and this slide shows one of the main points is that Azure has a very comprehensive reach around the world. We're making as Azure engineering is our top priority is to be the world's computer, and as we're doing that, it's creating and investing in regions around the world and going to all these fantastic places and having it to have either full Azure regions or Azure edge sites. And so these are investments that we're making through now over 60 regions across the world, over 130,000 miles of fiber and subsea cable that we've actually been investing in to create these high-speed interlinks between the regions, as well as having what we call express route partners, which express route in Azure parlance is our high-speed connection to go from a co-location or customer data center into an Azure region. So that way, it's while they're still transitioning off of their data center, it's as if they can have a direct connection and see Azure artifacts as if it was on their same network through virtual network peering and other similar technologies to accomplish that. So that's part of that hybrid cloud pattern that we as Azure are very keen and think that is a great investment as we are wanting to create options for customers as they're transitioning into the cloud and have those abilities. Now, when it comes to the legacy artifacts and why that's important is that, as John mentioned, these systems, SPARC, Solaris, the DEC family, the PA-RISC family, these are systems that are distributed and live around the world internationally. And Stromasys has customers from across the world. So with Azure having a global footprint and having regions everywhere from on all the major continents, we are able then to meet the customer where they are for those. I'll then actually want to talk about when it comes to compliance and when it comes to our government customers as well. So as John had touched upon earlier, that a lot of these systems are also critical, mission critical systems, high risk systems. Sometimes they are used by federal governments of either the United States or other international governments, and therefore they are have regulations that are very important.
Going to go through all of these certifications one by one, are you?
Yes, and that would be a great way to. This could be a podcast for letting us fall asleep.
Yeah, episode 2, we'll do that one in. But yes, but seriously, this is very important, isn't it? Because of course, a lot of these applications are by definition in government, they're mission critical, they're health critical, they're whatever they are. That needs to you've got to be mindful of that.
Exactly, and so this slide here just shows the comprehensive nature that we have. That we have great regulation compliance requirements that we've met for U.S. government, for high impact level, for DoD, and for of course FedRAMP and FedRAMP High. But also international, we also are meeting requirements for other sovereign requirements as well. So that way we are trying to meet them where they're at. Then we also have various sovereign clouds, not just in the United States, but also internationally as well, in order to help meet those requirements.
I've got a question about licensing here. So what happens if you're licensing, you have your Oracle database license on your legacy platform, and then it's suddenly you're in Azure. Do you need different licensing?
So there is some different licensing when you're going from your on-prem into Azure. However, there are agreements between Microsoft and Oracle where there are options for having a cloud interconnect between Oracle's cloud and Microsoft Azure. But it is completely possible to run an Oracle database on an Azure VM. And we have customers who are doing that today. I've worked with customers for doing that migration pattern where they still want to run Oracle database, whether it's Oracle, an older version like Oracle 10 or 11, or a slightly newer one like 12 or 18, where they can then run that on a Linux Azure VM and get quite good, get very, very good performance, and it meets their needs completely. Now, from a licensing standpoint, I'm on the engineering side. That's not my core area, but what I can say is that it has been and it is possible to do.
Okay, good. So let's have a look at how this works. And I have to say, you two guys are real detail guys. You've got some, you have got some excellent conceptual diagrams coming up here. So first of all, John, this is for you. There's a dotted line going around, going across the middle of this, and I've got a sense that what happens above the line and below the line is very different.
Indeed. So here you have a stack, which is your current environment, the one that is.
So that's on the left, yeah.
Yeah, the big red blip there. That's your legacy hardware. It might be SPARC or VAX or any PA-RISC HP 9000. And on top of that, you got the software stack that you need to preserve, which starts with the OS, and then it has your application and your database. And that blue you want to preserve. So basically, you take that blue. Well, let's start with the red one. You forget about the red one. You replace it. You replace it with an Azure virtual machine. It's modern x86 environment. Don't need to talk here about why cloud. I mean, they're going to be taking care of it for you, and you will never have again this problem because somebody else is managing the hardware. And then on top of that, you put, we'll do it for you. We'll put Linux and then our Karen emulator. Karen is our Stromasys emulator. And then on top of that, you take the blue bits, the application, the database, and any layered software, and you just lift and shift it across. And you place that in the cloud without any modification, importantly, without any recompilation. Next day, the users come in, they log in with the same screen, the same user ID, the same password. Nothing has changed. Sometimes they might say, something has changed, it's going a bit faster. Is this a good day, or is it something really?
You hope. Now, you do say the next day. Now, clearly, you must be simplifying there. There has to be some change over time. How long does this process take?
Well, there's two different things here. One is how long will the work take? And the other one, what will the user experience? The user, we will plan this transition in a way that it has minimum failover, sometimes no failover time. Or it might be a few hours at night. So as far as the user is concerned, no, it really is the next day. Now, how long does the work take? That depends. It can take a few days. It can take much longer than that. That really depends on the customer's change management readiness and procedure. So if you as a customer know what you want to do and exactly where you want to go, and importantly, how you want to do that, what are your pain points? What are your security issues that we all need to be aware of? How will this move happen? Then we just sit down together with the Azure engineering team. We architecture this, we plan it step by step, and then it just happens. So, I'm not avoiding the question. It really has taken 3 days. When we do migrations, our standard time is 3 days actually per server. And there can be a lot of parallelization there. Or it can take months of planning and that's okay. If the customer needs to, there are many different departments. There's the legal, there's the security that need to approve everything. There is the management, the stakeholders, the users, all of these it's quite a complex process for very large organizations.
Your customers do this only once, probably. You do this all the time. So do you help them through this and say, we've been here before, do it this way, don't do it that way?
Absolutely. And I'm very pleased to say that the Azure engineering team know our software as well as we do. Sometimes even better. And they've really kicked the tires and opened the hood, and they've written their own manual, their own migration procedures, and they're on top of that. So both we and Jonathon's team are working close together. We're close to the customer, guiding them step by step, and especially in the design phase. And then we will watch over the people who will do the actual migration, unless it's a Microsoft or a Stromasys team, and we'll work with them, educate them, train them, certify them, and then we are watching and solving problems as they come.
Jonathon, I'll bring you on in on that one. I mean, it looks, when you have diagrams like this, it looks beautifully simple. Is there a lot of hard work to be done to get from out of the red square into the nice green square there?
It's surprisingly not that complicated. Once you have your foundation set up, and with, as John mentioned, graciously, we have an 88-page guide that I wrote with the help of John's team that walks through the steps of getting everything set up. And really, it's only 88 pages, not because it's super complicated, just because we wanted to go through each detail of how it works. And in the case of getting this up and running, really a lot of it is your very vanilla Azure components that you're setting up, getting your virtual network, getting your VMs, getting your base Linux environment optimized. And once you have that foundation, you have your networking figured out, you have your IP addresses mapped out. Then from there, installing the Karen emulator is very straightforward, and is you're able to get up and running very quickly. And then from there, doing the actual migration itself can be as simple as doing a UFS dump backup, which is a Solaris and Unix term for doing a data backup of your source environment, and then bringing that over. And then there's various ways of getting data into Azure, whether that's using command line tools that are very easy, like AZ copy, or if you're on ExpressRoute, there's other options there. Other options like Azure Data Box. If you have terabytes and terabytes of files, then there's options such as actually having a physical crate of hard disks shipped to your on-premises data center, which you can then have trucked into an Azure data center, if that's something that makes sense. It's a very low cost to the customer solution, but obviously it takes a bit more time for the trucking and shipping. But from there, setting it up is then as easy as doing using Solaris as the example, a Solaris setup and then restore. And then so as John mentioned, how it depends. If you're only doing a couple of these environments, it really can be quite quick and simple. If you're doing hundreds or thousands of these, then it really becomes, as John said, a change management process where you need to think about the kind of a factory model of how you're going to chunk through that many. But once you have the process figured out and done for 1 to 3, it's a very repeatable process from that point forward.
It sounds like a giant version of like when I buy a new laptop, about how so you're either buying sort of one laptop, or maybe sometime you'll be buying 10,000 laptops and migrating over. But it sounds like clearly there's more complexity to that, but it's the same basic idea, isn't it?
It is. The lot of similarities in that concept, absolutely.
But not so simple, because look at this. Tell me about this architecture, Jonathon. What have we got here? And I'd have to say to anyone who's squinting at this and saying that's a bit small, well, there was a lot to get in. You can download the slides and you can look at it later.
Sure can. You can download the slides and look at it. Also, this is one of our architectures that we published on our Azure Architecture Center, where we are building a library of architectures that for legacy artifacts into Azure. And this was actually our first premier architecture that we published with the help of John's team, and very proud of this one. So what this diagram shows here, we try to be as accurate as possible in showing the actual bits and pieces of how this thing actually works in Azure. And so kind of walking through it kind of left to right is that, first you have your on-premises users. As John mentioned, they really don't see a difference whether it was on-premises or in Azure, especially if the customer has either ExpressRoute or what's called a site-to-site VPN, where when they would log into these servers, whether it was through SSH or through a desktop emulation protocol, they would simply do the same thing as they did previously. And the IP addresses may change or they may not change depending on how we can architect the network. And there's options around that. And that's one also the benefits, is that we could even potentially keep the IP addresses the same in the target environment, as those can be hard coded sometimes in old code, and can be very tricky to change. And that's part of that complexity of migrating, and where the rehost lift and shift can save some time and effort. Now, moving towards the right, what we're doing here is that we're showing how we're kind of decomposing and we're scaling an environment across multiple Azure VMs. So the three blocks in the middle there, with the blue desktop icon, so the Azure virtual machine, the three of those across, those are Azure virtual machines running Linux, and typically Red Hat, but also CentOS is supported by Stromasys. And what's interesting here is you'll notice that on the two on the right, they're VMs, but they also have Solaris VM1, Solaris VM2. So what's actually possible is we can actually have nested VMs running. That's how this emulator actually works, is that you have a virtual machine running in Azure, but then through the power of the Karen SSP emulator and agent, you're then able to then have child VMs running. Now, it may make sense to only have a 1-to-1 ratio, depending on your performance profile of the source environment. And if you want to maximize the speed of that parent VM, then you may only want to go with one. However, if you're coming from older environments, again, using Solaris SPARC as the example here, then it might make sense where you can consolidate and actually have 2 or 3 running on the same VM and actually get some cost savings that way, where you're only paying for one Azure VM, but getting 3 Solaris environments, and therefore minimizing your Azure costs to you. The other main detail here to point out is the network interface card. So this is really interesting, where each of these child VMs, even though they're within the parent VM, through the power of Azure, we can simply either script or do it through the portal, add more network interface cards to that parent VM. And that's what allows us to give a dedicated IP address to those child VMs. Therefore, when you're addressing those VMs, it's as if there are another VM running on Azure, and they have their own dedicated IP address. It can be a static IP address. It can also, if you wanted to, you could even create a public IP address on that. Of course, depending on your security requirements and what you're trying to achieve, that may or may not be what you want to do, but it's actually possible to do. So then on the far left VM, we have the SSP director and the SSP manager. So these are the tools that Karen provides for overseeing your portfolio of your child VM. So that way you can turn your VMs on and off. You can check their various stats and details all from one area. So that way, if you're an administrator, you only need to log into that one Azure VM and then work on the director and manager. And that then has access and control into your other VMs and your other child VMs across there. In theory, you could run all of this on one Azure VM if you wanted to, but we wanted to show a little more realistic example of how in the real world you'd probably would scale this out across multiple VMs if you have a larger estate that you're migrating over. 2 more points I'll make on this architecture is that we're also using SSD managed disks. So again, by virtue of just moving into Azure, the disks that are running and housing the Solaris VM data, also the parent Azure VM data, is a premium SSD disk. So you're getting SSD disks right out of the gate by virtue of being in this environment. And so that's another just key bonus that happens by just moving into Azure with this architecture. Lastly, the main last point I wanted to cover is the Azure storage account on the bottom. So earlier we touched upon this, how if you have physical tape today on premises, which some firms have because of regulatory requirements, they have to keep a giant safe or archive of old tape for so many years, and they have to hold on to that. And then it also deteriorates over time. There's actually physical wear that happens on the tape, and it can be a challenge for these customers. Well, the Stromasys Karen SSP tool set includes a virtual tape emulator as a core component. And what happens then is that you can point that emulator of virtual tape, you can put it on an SSD managed disk, but what we did in our testing in our lab, and now we're doing with customers, is to use Azure Storage Account, and we can mount that as an SMB 3.0 mount on the Linux VM. So the parent Linux VM sees the Azure Storage Account as a mount point, as a drive. And then from there, the Karen SSP agent is able then to look to mount that mount as a place for the virtual disk in virtual tape emulator. Therefore, it goes from the Karen virtual tape emulator to the SMB 3.0 mount onto the Azure storage. And so by doing that, where you're able to get very petabyte scale and low cost storage that's serverless and has replication natively built in to the Azure storage account, that you're able to leverage that technology with very little changes. And then your applications running on Solaris still have no idea that this change happened. It's transparent to them. So there's no change needed for that aspect. So there's some of the examples of what you get just by very little changes, very few tweaks, and no change to your source application.
Yes, because that last bit is very interesting. I was going to ask about that because, of course, data resilience and availability backup, all these things, very, very important when you're looking at these applications. And what we're basically saying is the application itself doesn't know that anything's changed, apart from, the performance, I assume, is going to improve on that.
Yes.
And but it's all being done within the Azure environment.
That's right. Exactly.
Okay. See, I knew there was going to be a lot to discuss in that.
Yeah.
As well. Now, this one's simpler, but it's still pretty important as far as I can work out, isn't it? What's this abstraction layer?
Yeah. Thanks for sliding over to this. So this really is where do you go for the next step? So as John touched upon, and I think Tim, you had mentioned earlier in the talk here, that okay, you have your workload, you bring it into Azure, into the cloud, you're able to leverage some of these great capabilities of the modern networking, the Azure storage accounts, and that's a good first step. But depending on the context and the profile of the application, what is it serving? Is it serving an application today? Are there downstream internal users, customers, external customers, users who are using this workload? And are they on also an archaic interface level that they're using, interface layer? Or are there other interconnections with other systems that are needed to talk, read, and write to this system? And so the thinking here is that there are some powerful tools that Azure has in the cloud, such as the Azure API Management and API Management Gateway, which allows you to create an abstraction layer where you can create your own API endpoints with your own rules, your own security, your own token management that then could then talk into, say, for example, custom code running on a Solaris SPARC environment, where if you're able to expose those endpoints, that is possible in theory then to expose those to the Azure API Management Gateway, and then create modern applications used by users who maybe they're using a mix. It might be not only the Solaris SPARC environment, but maybe there's a new component that lives alongside it that the customer is developing, but they can't quite get rid of that Solaris environment, so they can have both kind of living in harmony together, but then have one common abstraction layer, management layer of API, where then all their modern development, modern apps, and so forth just talk to the abstraction layer. So as they're working and doing things and improving things on the back end, that's abstracted from the modern application development. So this is just kind of one vision of what could possibly a user and a company could do, a development team, as they're trying to get the most out of the cloud while still using these legacy artifacts.
So is this speculative, or is this happening already, that you've got this sort of development? So you've got basically the two sides of the IT department here, and you're the interface in between them.
It's not speculative in that we have been working on this in our labs, and so this is something that we've been prototyping, and it's something that I'm excited that hopefully soon we'll actually have a customer deployment with this pattern. But we're doing this pattern with other customers already, whether it's been with the Stromasys legacy, but for other legacy environments, this is a common pattern that we're seeing out there, not just Microsoft, but also other clouds as well.
Okay. It is a huge development. I mean, it means that your legacy application can live forever.
Yes, I can see the. I mean, you can see the sense in that as well as a sort of like an organizing of activity of taking away the problem in managing to modernize without having to completely change everything.
And you continue deploying very modern tools and features in your application, in your new applications. It's no longer the old application slowing you down.
Yeah. Now, talking of slowing down, the question I've got to ask both of you guys about is, when you stick it into Azure, then what's the performance like? Jonathon, first of all, what sort of what VM types do you use here?
Yeah, no, this is a great question, and because we showed that earlier architectural slide where we're showing VMs, but then a great question is, well what's the Azure class of VM that those were? So what we've done is, as my group and myself has partnered with John's engineering team, we have a great engineering cohort between us as we've done benchmark testing, we've done research, we've done collaboration on this. And what we found through those activities is that the F series and the H series have found to have the most optimal performance for running, in particular, the SPARC Solaris workloads. Mm-hmm. That's where we spend a lot of our focus so far. But we're also working on doing this for the other workloads as well, such as the PA-RISC and the DEC family. But what we can say is that the F series and the H series have had surprisingly and I shouldn't say surprisingly, but surprising when you're comparing it to the on-premises hardware, which had a lot of investment. SPARC processors there's a lot of work put into them. Mm-hmm. They were at the time very cutting edge processors. Mm-hmm. And so thinking about putting that into Azure, where we have a emulation layer happening, that we're having to the key secret sauce, the key brain power that happens with the Karen emulator is the fact that it's emulating this, in the case of Solaris, the SPARC processor, but it has to go through the emulation layer and then go to the Azure VM. Now, so what we found with the F series in particular is that that's where we found the most bang for your buck, where you have good performance while the cost of the Azure VM is a bit lower compared to the H series being our high performance computing machine, which had naturally better performance, but it's a higher cost machine per hour usage. So there are cases where you may want to use the H series. There's cases where your old legacy artifacts were such that in order to match the performance or get close enough, you'd want to go to the H series. The F series was one that for your more standard and older SPARC processors, you're going to have pretty good parity with that. And what I can say is that I'm being perhaps overly cautious in my language, because we did do benchmarking, and we actually found that on some of the industry standard tests, such as the CNT 2000 tests that are commonly used, that we had better performance than the baseline. So by actually running these tests on the Azure environment, on the F series, on the Solaris SPARC operating system, we actually beat the equivalent of what the on-premises system would be, which is very surprising. We're happily surprised. We were hoping would get close, but we actually beat it in some cases. So that made us very proud of that accomplishment.
That's important, isn't it, John? Because when we're talking about bang for the buck, unless you've got a certain level of bang, then it doesn't matter what the buck is.
Well, the buck always matters.
Well, the buck always matters, but you've got to have a certain amount of bang. You take my point.
Yeah, exactly. Yeah. So, I mean, if any software company knows that testing is at the core of being consistent and offering quality, and we do hundreds of tests, performance, functional, and all sorts of things. But what's different in the legacy world is that every environment is different. Every stack is different. Every legacy application has its own things that are not identical with everything else out there in the world. So you gotta be careful and caring about what it is that you're moving. More caring than careful. With care comes they go together. So it's I would encourage people not to just look at a published benchmark, though these are important at the early stage of the decision making. But as Jonathon said, to test it in your lab or in our lab, test your particular application and see what what it produces.
I was
what
going to
bang it
say,
gives
you can have a reasonable idea of the sort of performance you're going to get before you actually try this thing out. You can give people a certain amount of confidence that they're going to get what they're expecting.
Yeah, and speaking of bang on the buck, I mean, the earlier migration options that we were talking about earlier, that's 10 times the cost, 100 times the cost.
Yeah. Yeah, absolutely. All right, we're nearly at the end now. So I have to ask for both of you to give some advice to anyone who's been inspired by this to say, I really want to give this a go. And then one day I can be around for when we unplug the VAX or the SPARC or whatever. So what's the first steps? John, you go first.
Well, obviously you call us or you email us, or Jonathon. Well, you can also go on the marketplace and download it and play on your own. Again, but for a more complex situation, we would encourage you to have a conversation with Jonathon's team or with our team.
Mm-hmm. Jonathon, what do you recommend?
Yeah, I mean, John said it very well, and I'll just build on that by saying that for some quick information is that, you know, there's some great links here. So that one of them is to the Azure Architecture Center, where we have that diagram that we showed with more of a write-up around it. So if you just want to have a synopsis and get more comfortable with the concepts and how it works, that would be a good starting point. So it's about a two-page web page to get through. And then if you want to go a little bit more into the advanced class, there's the 88-page ebook, which definitely recommend to at least skim through. It'll give you the idea. And if you're familiar
it's
already,
not for everyone, but for the people that it is for, it's a valuable resource. Yeah.
That's right. And the one thing about it is that we try to be as detailed as possible. So that way, if you're even not familiar with even Azure that well, you're not familiar with even Solaris that well, it walks you through things step by step. So that way, it's trying to be like a nice clear guide of all those aspects. And then from there, I would say the Azure Marketplace template, as John mentioned, that's out there. It's available, and you can create if you have a developer account through Microsoft, you get $100 a month free that you could leverage, and so that you'd use that to download instantiate, I should say, the marketplace image in your subscription, and go from there. And so there's options for that to get up and running and start playing with it.
Great. We'll have a go, everyone. See what comes. See what happens. What's the worst that could happen? I shouldn't really say that, but yeah. I mean, but you stand to gain quite a lot, is what I should.
The most important advice is recognize that there is a lot of invisible risk there, and it's time that you face it.
Yeah.
And do something about it.
Yeah. Doing nothing is not a good option, as you say. Great. We're at the end now, so I would just like to say to Jonathon and John, thank you very much. Thanks for that.
Thank you.
Thank you.
And for all of you who came along today to see this, I hope you got what you wanted. I think we have one of the better diagrams that we've ever explored on a Regcast today. And I think, we got a few, but joking as it was, it's an extremely important explanation tool for something that, it's so important to get this right, but there's a way to get it right. So let us know how you get on with it. If you get into this, we'd be really interested to know. Let us know if you want us to do some more of this. We do more of what you want at the Reg, if you ask us. But meanwhile, from the two Johns, from everyone at the Register, and from me, Tim Phillips, thanks for watching, and goodbye.
Thank you.